On September 12, 2019, at exactly 3:47 in the afternoon, a US Coast Guard helicopter spotted something unusual in the Pacific Ocean, approximately 200 miles southwest of the Galapagos Islands. From above, it looked like a large piece of driftwood floating slowly through the turquoise water. But this was no piece of wood. This was a vessel that cost over $1 million to build, carried a cargo worth $165 million, and represented the culmination of 3 decades of secret engineering evolution. This was a narco-submarine, and the story of how these machines evolved from crude floating boxes into sophisticated stealth vessels is one of the most remarkable engineering tales of our time. The year was 1993. In a remote swamp near Barranquilla, Colombia, police stumbled upon something that made no sense. Half submerged in murky water sat what appeared to be a shipping container, welded to 55-gallon drums. It was painted dark blue. It had a small outboard motor attached to the back. Inside, investigators found crude, hand-drawn blueprints, welding equipment, and residue of cocaine. This primitive contraption could barely be called a vessel, yet it represented the birth of an industry. Someone, somewhere, had decided that the future of drug trafficking wasn't in fast boats or hidden airplane compartments. The future was underwater. These first attempts were laughable by today's standards. Built from scavenged materials, sheet metal, fiberglass panels stolen from boat repair shops, and industrial sealant, they leaked constantly. They moved at barely 5 miles per hour. Most sank before reaching their destination, but they proved a concept. If you could stay below the radar horizon, literally and figuratively, you could become invisible to the billion-dollar detection systems of the United States Coast Guard and Drug Enforcement Administration. But before we continue, leave a like if you're already curious to see how these machines evolved into the sophisticated vessels they are today. By 1997, the design had evolved. In the dense jungle of Tumaco, Colombia, along the banks of the Mira River, a new generation emerged. These weren't submarines in the traditional sense. Engineers call them low-profile vessels, or LPVs. Picture a 40-foot-long cylinder, painted ocean blue, sitting so low in the water that only 18 inches of hull breaks the surface. The profile is so minimal that from just half a mile away, even in clear weather, the human eye struggles to distinguish it from the endless pattern of waves. The construction process was elaborate and dangerous. Deep in territories controlled by the Revolutionary Armed Forces of Colombia, shipyards operated 24 hours a day. The sound of generators hummed through the jungle. Welders worked under camouflage netting. Materials arrived on pack mules, traveling for days through mountain passes. Fiberglass panels, marine diesel engines, lead ballast weights, hydraulic systems. Everything had to be carried by hand to locations that existed on no map. The design itself was ingeniously simple. A single hull divided into 3 watertight compartments. The forward section held cargo, typically between 4 and 6 tons of cocaine hydrochloride, vacuum-sealed in packages and stacked like bricks. The middle compartment housed the crew, usually 4 men, sitting in a space no larger than a minivan interior. The rear compartment contained a single diesel engine, a fuel tank holding 900 gallons, and a basic exhaust system that vented through a small pipe barely visible above the waterline. Navigation was primitive: a magnetic compass, a handheld GPS unit powered by AA batteries, a depth gauge scavenged from a recreational fishing boat. Communication was forbidden. Radio silence was absolute. These vessels left the Colombian coast and vanished for 10 to 14 days, crossing over 1,200 miles of open ocean to reach drop points off the coast of Guatemala or Mexico. Success rate? Approximately 73%, according to estimates from the Office of National Drug Control Policy in 2003. But the cartels weren't satisfied. 73% meant that 27%, roughly 1 in 4 submarines, was being intercepted. That represented losses of over $150 million per vessel. The engineering had to improve. By 2006, it did. The second generation of narco-submarines appeared between 2006 and 2010, and they represented a quantum leap in sophistication. These vessels stretched nearly 60 feet in length. They displaced 22 tons. They could carry up to 8 tons of cocaine. And most importantly, they could travel at 12 knots, or approximately 14 miles per hour, for over 2,000 nautical miles without refueling. The hull construction changed dramatically. Instead of simple fiberglass, builders began using a composite layering system, an outer shell of marine-grade fiberglass, reinforced with Kevlar strands stolen from body armor manufacturers. An inner layer of closed-cell foam insulation that provided both buoyancy and structural rigidity. Between these layers, a framework of PVC piping and wooden ribs created a geodesic structure that distributed stress evenly across the hull. The result was a vessel that weighed less, but could withstand significantly more pressure. The propulsion system evolved. A single Detroit diesel 8V92 engine, the same model used in city buses across America, provided 450 horsepower. This engine was chosen specifically because replacement parts were readily available and because its distinctive sound signature could be muffled using automotive exhaust baffles welded in series. The drivetrain, connected to a single 5-blade bronze propeller, custom machined in machine shops in Panama City and smuggled south in pieces. The crew compartment became marginally more habitable. Instead of sitting hunched over for 2 weeks, crew members could now recline on foam pads. A small chemical toilet replaced the buckets of earlier designs. LED lights powered by a 12-volt marine battery provided illumination. Ventilation improved through a more sophisticated air handling system that drew fresh air through a snorkel tube and exhausted stale air through one-way valves in the hull. On July 19, 2008, the Coast Guard cutter Boutwell intercepted one of these second-generation vessels 350 miles off the coast of Guatemala. The boarding team's helmet camera footage shows the incredible attention to detail. The hull was painted a specific shade of blue-gray that exactly matched the color of the Pacific Ocean under overcast skies. The vessel's waterline was calculated so precisely that it sat with exactly 16 inches of freeboard, the optimal height to avoid both radar detection and swamping in moderate seas. Inside, investigators found navigational charts marked with coordinates, speed calculations, and fuel consumption rates, all computed by hand with remarkable accuracy. But even these impressive vessels had limitations. They couldn't fully submerge. They were still vulnerable to aerial detection. In 2009, the U.S. military began deploying P-3 Orion aircraft equipped with synthetic aperture radar, specifically designed to detect low-profile vessels. Detection rates began climbing. The cartels needed another evolution. By 2012, they delivered it. The third generation introduced true submersible capability. These vessels, which first appeared in intelligence reports in late 2012, could dive to depths of up to 30 feet. They weren't traditional submarines with pressurized hulls and complex ballast systems. Instead, they used a simpler but equally effective approach called snorkel technology. Picture a 65-foot vessel with a hull shaped like a teardrop, hydrodynamically optimized to move efficiently underwater. The top of the hull features a retractable snorkel mast, similar to those used by World War II submarines. This mast, approximately 4 inches in diameter and extending 8 feet above the hull when deployed, serves 3 critical functions. First, it draws fresh air into the crew compartment. Second, it provides oxygen to the diesel engine. Third, it expels exhaust gases. When the snorkel is retracted, the vessel can run on battery power alone for short periods, becoming completely invisible to surface detection. The construction of these vessels required genuine engineering expertise. In November 2013, Colombian National Police raided a shipyard near Bahia Solano and arrested a man named Miguel Angel Gonzalez. Gonzalez wasn't a typical cartel member. He held a degree in marine engineering from Universidad Nacional de Colombia. For 8 years, he had worked as a legitimate naval architect designing fishing trawlers. Then the cartels recruited him, offering a payment of $200,000 per completed submarine. His designs incorporated principles from actual submarine engineering, ballast tanks that could be flooded or pumped dry to control buoyancy, trim tanks at bow and stern to maintain level attitude underwater, a pressure-resistant conning tower where crew could access the snorkel controls. The propulsion system became even more sophisticated. Instead of a single large diesel engine, these vessels used 2 smaller Cummins 6BT engines, each producing 210 horsepower. This dual-engine configuration provided redundancy. If one engine failed, the vessel could continue on a single engine, albeit at reduced speed. The engines connected to a hybrid drivetrain that could switch between diesel power for surface running and electric power for submerged operations. The electric system used 24 deep-cycle marine batteries, the same type used in electric forklifts, arranged in series to provide 288 volts. This battery bank could power the electric motors for approximately 6 hours at 5 knots, enough time to evade immediate threats before surfacing to recharge. Navigation became digital. A GPS unit with a waterproof external antenna provided real-time position data accurate to within 10 meters. A solid-state compass eliminated the errors of magnetic compasses in metal-hulled vessels. Most remarkably, some of these submarines incorporated a periscope system, not an optical periscope like you see in movies, but a fiber optic camera mounted at the top of the snorkel mast, feeding video to a small LCD screen in the crew compartment. This gave crews situational awareness, even when fully submerged. On February 14, 2015, the Ecuadorian Navy intercepted one of these third-generation submarines 180 miles off the coast near Esmeraldas. The vessel was traveling completely submerged at a depth of 22 feet. It was detected only because a maritime patrol aircraft spotted a small thermal signature from the snorkel exhaust. When divers examined the captured vessel, they found engineering details that shocked investigators. The hull featured a sonar-absorbing coating, similar to anechoic tiles used on military submarines, made from recycled rubber tires, ground into fine particles, and mixed with marine epoxy. The propeller was a 7-blade design that produced minimal acoustic signature. The interior was lined with sound-dampening foam to reduce machinery noise. This wasn't a crude smuggling vessel. This was a legitimate submarine built with counter-detection technology. But the evolution didn't stop. Between 2016 and 2020, a 4th generation emerged, and it represented perhaps the most audacious engineering achievement yet. These are fully electric submarines. In September 2020, Colombian authorities, guided by US intelligence, raided a shipyard near Tumaco. Hidden under triple canopy jungle, accessible only by boat, they found a completed submarine unlike anything seen before. This vessel was 40 feet long, shaped like a cylinder with hemispherical end caps. It had no diesel engine, no exhaust system, no snorkel. Instead, it was powered entirely by lithium-ion batteries. The battery system was extraordinary. Investigators counted 320 individual lithium-ion cells, each the size of a car battery, arranged in 10 banks of 32 cells. These weren't standard marine batteries. Analysis revealed they were the same high-density cells used in Tesla Model S electric vehicles, likely purchased through intermediaries in Chile and Peru. The total energy capacity was approximately 500 kilowatt-hours, enough to power a typical American home for 2 weeks. In a submarine, This energy could drive 2 electric motors, producing a combined 180 horsepower for approximately 18 hours at cruising speed of 8 knots. But how do you recharge 500 kilowatt-hours of batteries in the middle of the ocean? The answer was as ingenious as it was illegal. These submarines weren't designed to operate independently. They were designed to be towed. The towing system worked like this. A legitimate cargo ship, a fishing trawler or container vessel, would depart from a South American port carrying legal cargo. Hidden in a specially modified cargo hold, secured with quick-release clamps, sat the fully loaded electric submarine. When the mothership reached international waters, far from patrol routes, the submarine would be deployed through a moon pool, a hole in the bottom of the ship's hull. The submarine would attach to the mothership via a 300-foot towing cable made of braided Kevlar, nearly invisible to sonar. The mothership would then tow the submarine at depths between 40 and 60 feet for thousands of miles across the ocean. When approaching the destination, whether the coast of Mexico, Spain, or West Africa, the submarine would detach from the towing cable, activate its motors, and proceed independently to a predetermined drop point. After delivering its cargo, the submarine would flood its ballast tanks and sink to the ocean floor, erasing all evidence. The mothership would continue to its legitimate destination port, customs inspectors finding nothing suspicious. The sophistication of these vessels is staggering. The hull is made from carbon fiber composite, the same material used in Formula One racing cars, providing incredible strength at minimal weight. The control systems are digital, using programmable logic controllers, or PLCs, typically found in industrial automation. The navigation system includes an inertial measurement unit that can track position even without GPS, using accelerometers and gyroscopes to calculate movement with remarkable precision. Only one of these fourth-generation submarines has ever been captured on land. None have been intercepted at sea. Intelligence analysts estimate that between 12 and 17 of these vessels have been constructed since 2018. Their success rate is believed to be approximately 95%, far higher than any previous generation. The economics driving this innovation are staggering. A kilogram of cocaine costs approximately $1,800 to produce in Colombia. That same kilogram sells for $28,000 wholesale in the United States and $50,000 in Europe. A submarine carrying 6 tons or 6,000 kilograms represents a potential profit of over $250 million. Even accounting for construction costs, crew payments, and the 25% of vessels that are lost or captured, the return on investment exceeds 800%. No legitimate industry offers margins like this. The financial incentive to innovate is overwhelming. The master builders who design these vessels have become legends in the intelligence community. They are known only by nicknames: the engineer, the professor, the ghost. These individuals possess skills that would make them valuable employees at any legitimate shipyard. They understand hydrodynamics, structural engineering, electrical systems, and propulsion mechanics at a level that requires years of formal education or decades of hands-on experience. Yet they work in jungle clearings, using hand tools and improvised equipment, building vessels that rival the sophistication of military hardware. In 2021, the Drug Enforcement Administration's Operation Martillo resulted in the capture of a man believed to be one of these master builders. His name, which remains classified in court documents, and his background reveal how cartels recruit talent. He had worked for 15 years as a maintenance supervisor at a commercial shipyard in Cartagena. He understood welding, machining, and marine systems. When cartel recruiters approached him, they offered $500,000 to design and supervise construction of 3 submarines. He agreed. Over 4 years, he built 11 vessels, each more sophisticated than the last, before his arrest. The technology continues to evolve. Intelligence reports from 2023 suggest that fifth-generation designs are already under development. These vessels may incorporate autonomous navigation systems, artificial intelligence for route optimization, and even more advanced stealth technologies. The cat-and-mouse game between smugglers and law enforcement has driven an underground arms race that shows no signs of slowing. The United States Coast Guard intercepts approximately 1 in 5 narco-submarines. That statistic represents both a success and a failure. Success, because 20% interdiction rate translates to billions of dollars in prevented drug sales. Failure, because 80% still get through, delivering their cargo and generating profits that fund the next generation of innovation. On December 3, 2022, at 11:23 in the morning, a Coast Guard boarding team intercepted a second-generation submarine 400 miles west of Guatemala. The crew scuttled the vessel before it could be secured, opening flood valves that sent 8 tons of cocaine, worth $210 million, to the ocean floor. The 4 crew members were rescued and arrested. In interviews, they revealed they had never seen the submarine before the day of departure. They had been given 6 hours of instruction on operating the vessel. They were paid $50,000 each. They knew nothing about who built it, where it was constructed, or who ultimately received the cargo. The compartmentalization was complete. The engineering genius behind the vessel remained free, already working on the next design. The story of narco-submarines is ultimately a story about human ingenuity directed toward illegal ends. These vessels represent some of the most impressive engineering achievements of the 21st century, built not by corporations with billion-dollar budgets, but by small teams working in impossible conditions with limited resources. They prove that necessity, coupled with enormous financial incentive, can drive innovation at a pace that rivals legal industry. From crude floating containers in 1993 to fully electric autonomous submarines in 2024, the evolution spans just 30 years, a remarkably short time in engineering terms. The future of narco-submarines remains uncertain, but inevitably more sophisticated. As detection technology improves, submarine technology will improve faster. As long as the profit margins remain astronomical, the innovation will continue. Somewhere in the jungles of South America right now, at this very moment, a master builder is sketching designs for a vessel that doesn't yet exist, solving problems that haven't yet been encountered, pushing the boundaries of what's possible with limited resources and unlimited motivation. The secret engineering of narco-submarines isn't just about drugs or crime. It's about the incredible things humans can create when consequences are irrelevant and profits are unlimited. These vessels exist in the shadows, unseen by most of the world, yet they represent a parallel engineering industry that rivals anything in the legitimate maritime world. They are testaments to human creativity, human determination, and the uncomfortable truth that genius can be applied to any purpose, legal or illegal, moral or immoral. The submarines will keep evolving, the cartels will keep building. And somewhere in the Pacific Ocean, right now, another unmarked vessel is slicing silently through the water, invisible to radar, invisible to satellites, carrying its illegal cargo toward distant shores, a floating monument to the engineering brilliance born from criminal necessity. The world of secret engineering goes far deeper than narco-submarines. If you're curious to explore more, leave your like now and subscribe to the channel. Until next time.